first example for decomposition reaction is FeSO4, right, and those ferric oxide plus harmful gases like SO2 and SO3. Can I write the first example as we seen that FeSO4 gives rise to Fe2O3 plus SO2 plus SO3. These are the harmful gases here, sulfur dioxide and sulfur trioxide. This is an ferric oxide. It is in green color and it is in white color. Because of the water content, we will discuss in the metals and non-metals chapter about water of crystallization topic. Do not worry about that. Now you see the single reactant gives the 2 or more products. It is called decomposition reaction and it is example for thermal decomposition. Okay. Example for thermal decomposition. Okay, now right. Another example you have balanced in the balancing chapter, right? Lead nitrate. It is a single reactant, but it gives what? Lead dioxide plus what are the gases are liberated? What are the gases are liberated like sulfur dioxide and sulfur trioxide? Here nitrogen dioxide and oxygen is liberated here. It is also a type of decomposition reaction. Single reactant gives us to many products, right? It is also another example for thermal decomposition. Now let us go for electrolysis. What is electrolysis? Electricity, lysis, breaking. Yes or not? Lysis means breaking. Let us discuss about that in a detailed way. What are all the content is there in that and what should be happening in the experimental setup and everything. Okay, no problem. Let us go with the electrolysis. Electro means electricity, lysis means breaking. Okay, it is an electricity. I will give an example of a decomposition reaction. You can write the definition like this, like decomposition reaction takes place in the presence of electricity. Yes or not? In the presence of electricity, the products are given. For example, water. When water is inserted to the electricity, then it divides into H plus and OH minus, or you can tell that O2. Okay, these are the ions present in it, or we can tell water ions. But when we do the electrolysis, the product is oxygen gas is liberated. Okay, H2 gas and oxygen, these are the ions. H plus and OH minus are ions. H2 plus oxygen O2, these are the gases here. G means gases. Okay, it is a liquid form. L, liquid. Okay, decomposition reaction takes place in the presence of electricity is called electrolysis, water. Now let us see the setup, what and all the electrolysis is done through. Very important question, very important for 2 mark or for 3 mark, definite question for the board examination point of view. Clear carefully. See, I am going to take a beaker, it is a beaker, and I am going to place an electrode. It is an electrode. Imagine it is an electrode. Another electrode. Whenever we talk about electrolysis, this setup should be in your mind. Okay, be aware of this. Electrolysis, it means it is a beaker setup. It is an electrode, and I am going to place a test tube or whatever, any beaker, small beakers in the upon the that electrodes. You can tell electrode as a pencil. Pencil is the best electrode. See, lead which is present in the pencil, it is a graphite. It conducts an electricity in the water. Okay, right. Now I am going to add some H2O, it means water, or some dilute H2SO4. See, we can take water here. See, it is a dilute H2SO4. We can take water here, whatever it may. If the water is poured, when the water is poured, it shows two gases in the two different electrodes. Okay. See, this electrode is connected to a battery. Okay, it is a battery. Okay, then to the battery there are the electrodes, right? What is the cathode and it is a anode. Anode is always plus in symbol and minus is cathode. Clear? Right. When we pass the electricity, when we switch on the electricity button, the graphite which is present, it is a graphite rod. It is a graphite rod. Okay, graphite rod. You can place it is a test tube. You can label test tube. Okay, it is a beaker. Everything is important so that the full marks, there is no any reduction of mass can be seen. Okay, we should get full mark. When the electricity is passed on this, then the bubbles started going to the electrodes with the respective. Before that, I did not on this setup. Still the setup is without off only. Let me tell something about water. See, water has two hydrogen. Okay, na? Water has two hydrogen and one oxygen. You can see no here H2O1 only. Then the ratio is 2:1. Hydrogen value is more than the oxygen. So when we on the electricity or when we pass electricity to the this particular beaker, then water started releasing some bubbles to the graphite rod. That particular graphite rod is captured on that particular rods or electrodes. These are the electrode, right? Cathode and anode. When the electricity is passed, then the gases are going towards that particular electrodes. Like at the cathode side, H2 gas is present. Okay, here H2 gas. Then to the anode side, we have oxygen gas. Okay, that particular phenomenon happened in the electrolysis because 2:1 ratio, which having more that will go to the minus, which has high it will go to the, which is has low it goes to the minus. It is a anode, it is a cathode. Is it clear? Right. Because the ratio of the hydrogen and the oxygen in the water is 2:1, it makes the water good conductor when we add the dilute H2SO4. See, water is a bad conductor of electricity. No, water is the bad conductor. See, when our hands are wet, when we switch on the button to the light or whatever, it shocks us, it harms us. When we pour the dilute H2SO4 to the beaker, then it becomes good conductor of electricity. The electrolysis phenomenon happen in that. Yes or not? This is the phenomenon of electrolysis. Okay, this is all about electrolysis. The setup you should draw, the gases where, and one more trick I want to tell you guys. Sir, how we can remember this gas is going to this particular electrode? Simple, yaar. See, cathode as H, no? See, let me write here. Cathode, it is a anode. Okay, cathode has H. Hydrogen is H. Hydrogen starts from H, no? So that you can remember at where H and H, then the gases is going to that particular cathode and oxygen is going to anode. Simple trick. Third type, photochemical decomposition. Decomposition reaction that takes place in the presence of sunlight. Right? This is the heat and this is the electricity and this is the sunlight. AgCl, Ag plus Cl2. Okay, a single reactant gives the 2 or more product. It is a decomposition. It is a type of decomposition reaction. See, AgCl is a salt, white salt. but when we keep it to the sunlight it becomes gray, okay, and we should balance this reaction. Same like in the place of Cl I have put it the Br, AgBr, Ag plus Br2, a simple type of reactions here, not much complicated like electrolysis and thermal, okay. But these are used for the black and white photography. On those days, in olden days, these two reaction, by conducting these two reactions, the black and white background is done through. By that the photos are coming like black and white. Now it is going to be colorful, okay. This is all about decomposition reaction, combination reaction. Everything should be noted in your book so that it is good for your revision or when the examination point of view there. And in the next session we are coming with the next type of chemical reactions. Until then, take care and practice all the chemical reactions, okay. Let me meet in the third session. Thank you. Fourth session.